All right, so in this video we're talking about absolute value functions. Now we actually talked about absolute value a little bit in the previous chapter, but now we're actually talking about them as functions. Okay, so here, what's the algebraic definition of the f of x equals absolute value of x? Well, if you recall from chapter 1, it was a piecewise function. Now that we know what a piecewise function is, we know the absolute value of x is equal to, and it's something like this. Well, it's equal to 0 if x was equal to 0. It was equal to x if x is greater than 0, and equal to negative x if x was less than 0. Okay, you've seen that before, and that's a piecewise function. We have restrictions in the domain, and we do certain things. Now, how is the function related to piecewise? Well, that's what we just did. Okay, the definition is a piecewise function. Now, this is called the parent absolute value function. We want to know what is the general absolute value function. So here it is. So y equals a absolute value x minus h plus k. You need to know this. So here, there's going to be certain things that we need to know. The vertex is located at h comma k. So this is kind of like our, if you want to think about it, this is our x, this is our y. That's the specific location where the vertex is, the bottom of our V or top of our mountain. The A tells us how narrow or wide. How narrow or wide the graph is. Okay? You need to know this. This is super important. Okay? Now, this is what I've pretty much just said. It's just summarizing. So, the graph has a vertex at the order pair h comma k. The graph is V-shaped. It opens up, meaning it makes a traditional V if a is bigger than 0. And if a is smaller than 0, meaning negative, then it opens down. It's going to look like the roof of a house. And the graph is wide if absolute value, it's going to be wider than the parent function if the absolute value of a is smaller than 1, meaning like a fraction, like 1/2. Or if the absolute value of a is bigger than 1, like 2, 3, 4, then it's going to be narrower or steeper than the parent function, y equals absolute value of x. Okay? So we want to graph this by hand. So first things first, I always like to compare it to the general function. So y equals a absolute value of x minus h plus k. So now it's very easy to pick out. Well, my order pair, my vertex, so here, h is equal to -2, k is equal to +3, and a is equal to -1. All right, now we know a couple of things. My vertex now lives at -2, 3. -2, +3, that's where the vertex lives, because that's what h and k tell me. Now a equals -1 tells me that it opens down. Meaning it's going to look like the roof of my house. Okay, it's going to look something like that. Now, the absolute value, it's going to be equal to 1, so it's going to be the same narrow. It's not going to be any steeper or any wider than the parent function, absolute value of x. So that's good. So now what I need to do is just plug in and make a table of values. So x, y. And what I'm going to do now is just pick a nice ordered pair. So let's say x equals -1. So when x equals -1, everywhere I see an x, I'm going to plug it inside. -1 plus 2 is +1. Absolute that is +1 times -1 is -1 plus 3, so that's +2. If you need to do that in your calculator, do that. No, I'm just kind of rambling on. Do it in your calculator if you need to. So I have my next point is right here. But hey, absolute value has symmetry, so I know that I buy one, I get one 3. And I could do more points, but I really don't need to because I know my absolute value is now going to be something like this. And that's it. I have my absolute value now. Okay, it's a little bit off because I didn't draw my line perfectly straight the way I should, so I'm going to redo that really quickly. Let's try to do that a little bit better. There we go. That looks better. Okay, so absolute value, like you said, A opens down. It's the same width as the normal absolute value function. Okay, write an equation for this guy, for this absolute value function graph shown. Now here, first view we want to start off with is my vertex. So my vertex right here is at negative 0, negative 3. So what it tells me is h is equal to 0 and k is equal to negative 3. Okay, so I'm going to plug it into my general equation. So remember, my general equation was y equals a absolute value of x minus h plus k. I'm going to plug in what I know so far. So where I'm at is I plug in my h and k, so I have y is equal to a absolute value of x minus 0 minus 3, or y is equal to the absolute a times the absolute value of x minus 3. Well, we still need to figure out what in the world is a. So what I'm going to do, that's kind of like our y-intercept, but it's not really, okay? All we're going to do is find a nice point on the graph and plug in for x and y. So here's a nice point right here. That point right there, it's 2, 1. So everywhere I see an x, I'm going to plug in a 2. Everywhere I see a y, I'm going to plug in a 1. So I'm going to do that, and all that's going to remain is my a. So I have 1 is equal to a, absolute value of 2, absolute value of 2, minus 3. Well, we need to get a by itself, so add 3 to both sides. So I have 4 is equal to a, and the absolute value of 2 is just 2, so we really just have 2a. And then just getting a by itself, we have a is equal to 2. Now we can write our equation. So just using this general rule now, we have our final answer, y is equal to 2 absolute value of x minus 3. Now if you're not sure about that, you can graph it yourself using your calculator, but it should look something like this. And that's how you do absolute value functions.